let's get started. We have some amazing guests joining us today. I'm just going to run around really quickly. If you can just say hello when I mention you. So first on my list is Tim Hockin, one of the original co-founders of Kubernetes, principal software engineer at Google. Hi, Tim.
Hello, Liz, and everybody. How are you doing?
Thank you. Wonderful. Dan Winship, who's joined us from Redhat, where he's principal software engineer, and he's been working for a long time on networking in OpenShift and in upstream Kubernetes, I believe.
Yep. Hi, everyone.
Thank you for joining us. We also have Thomas Graf, who is CTO at Isovalent and one of the creators of the Cilium project.
Hello, everybody. Glad to be here.
And we also have a great group of end users who are going to tell us about using network policy in real life. So from Datadog, we have Liliya Belaus, who's a senior software engineer.
Hi, happy to be here.
And we also have Eric Mountain, also senior software engineer from Datadog.
Hi there, happy to be here too.
And we have Peter Bale, who's a senior engineering manager from Sky.
Hiya.
And we have Joseph Samuel, who is a principal consultant at CECG, who's been working with Sky.
Hey, yeah.
Brilliant. So thanks everyone for joining us today. Let's get started by just talking a little bit about what network policy is and the history of it. I think one question that I was really curious about, Tim, is did network policy exist in Borg, which was commonly considered the predecessor to Kubernetes?
Interesting question. Yeah, I mean, a lot of the ideas in Kubernetes came from Borg, but we don't really have an equivalent to network policy per se. Borg, because we control everything from the application all the way down to the OS, we can dictate what apps do for inter-app communication. So we have our own RPC libraries. So everything's really policied at layer 7 instead of layer 3 and 4.
That's
but it was clear that
wasn't.
It was clear that wasn't going to work for open source applications at large, which was one of the prime targets for Kubernetes. So we needed to adapt to something that was more accessible to the rest of the world.
And perhaps a question for you, Tim, and Dan, you might also want to chip in on this one. I'm wondering what other implementations and projects influenced what we now know today as network policy in Kubernetes. Dan, do you have some thoughts on that?
Yeah, no, I was going to say I'm not really sure. You mentioned I've been working on this for a long time, but I think I started right after the initial design of network policy appeared from somewhere.
So network policy was the result of a lot of people working together, talking about stuff, throwing ideas out there. Obviously, it's inspired a little bit by the normal sort of firewall rules and those sorts of things, but we wanted to make it more app accessible, more end user accessible, and less network heavy. So we chose a really opinionated, very integrated model for that. But if you'd seen some of the early drafts, they look like basically IP tables turned into YAML, or other sorts of firewall rules that people are familiar with from other systems. And we started with those ideas and we pared down the things that we thought we could live without to try to get to a really sort of reductive model.
You mentioned IP tables, and that actually takes us to a question that came in on Slack yesterday, or our first question that came in on Slack from Dimitri S, who was asking about the state of the community replacing IP tables with BPF in the kernel. Thomas, do you want to tell us a little bit about the replacement of IP tables?
Yeah, so I think many of us who have been doing networking for a while probably we all have horror stories around IP tables in some way or shape, right? It's actually, I mean, IP tables is great if you look at how long it has existed. Like it's more than 20 years old, and we're still using it, even though it's definitely not the ideal kind of fit for most of the problems we have today. So it's no surprise that the desire came up eventually that like, let's replace IP tables with something that scales better, that is more native, that is closer to kind of an ideal solution to the use cases we have today, because let's not forget when IP tables was invented, we were still using dial-up modems, like very different time. So there has been an effort to replace IP tables, the kernel portion of it, as part of the Linux kernel solution. So to continue being, or to being able to continue using the IP tables as binary, but then the implementation being in eBPF. But honestly, what happened instead is that the projects that are using or want to implement firewalls, they're using eBPF natively. So I think what we will probably never really see it as full replacement of IP tables in this compatibility mode. What we will see instead is more and more eBPF native solutions taking over, doing load balancing, firewalling, and so on. I think with pretty much all the projects around networking in the cloud native space, I've heard the word eBPF in some way or form by now.
And presumably, network policy itself doesn't care about the underlying implementation. Is that correct? Like the definitions will work regardless.
You know, a lot of implementations use IP tables, but Cilium, of course, uses eBPF. OpenShift SDN, OVN Kubernetes are built on Open vSwitch as the security and processing layer. So there are a bunch of ways that network policy can be implemented.
I think maybe do I add something here? I think that was actually one of the strongest points of network policy, is that it did not make premature assumptions early on about how exactly it has to be implemented, which allowed a wide range of tooling or like foundations to be used for it, which allows even for, let's say, like there's been discussions around OVS switching over to an eBPF-based data plan as well. And all of that flexibility exists exactly because the network policy specification is at a higher level, like at an intent level, that gives the flexibility on the implementation side.
Yeah, that was all really an important consideration as we were designing it, because we knew at the time, this was like round about 2014, and we knew that BPF was sort of on the horizon as a likely next winner. And we knew that there were other ways that people would want to implement this stuff. So we had to leave room for it, which was very intentional as part of the reductive model also.
So one thing we haven't really talked about yet is, why is network policy important? So Tim, from when the early days, what was the kind of like first use case that you remember people talking about for network policy?
Well, the Kubernetes networking model assumes some amount of openness and flatness, and that came in part from lessons learned through the Borg world and some really interesting stuff that happened because the network was open and that apps could talk to each other. A lot of cool Google products have come out of people just tinkering and poking at services that weren't theirs, but seeing what they could do with it. So we wanted to retain that property, but we knew that we needed to give people some amount of control so that they could lock it down when they didn't want that. And the last thing we wanted was end users digging down into IP tables, because that was just going to end in tears for everybody. And so we knew we needed something that would allow you to lock these things down. We looked at the possible implementations, and you know, I wish we could have done more with network policy, but knowing what the implementations that were likely, like IP tables, they're pretty restrictive in what they can achieve. So we had to sort of keep it at the lowest common denominator of what the policy can express.
So when you said that you wish that you could have done more, what kind of things do you wish had been possible?
I mean, there's so many things that people are doing now that I wish we could still express in IP tables, and we simply can't. Like there's no notion of identity, right? And so you've got all these implementations like Cilium that build identity as a model on top of this, and they squeeze identity information either into the packets, or other systems will build it into the overlay mechanism. We didn't want to assume that there was going to be an overlay, because we wanted for people to be able to program natively when they were possible. But you know, we didn't want to. Sorry, we were forced to just limit ourselves to, like, we couldn't add any sort of L7 concept space at all. And so, you know, there's a lot of thinking now in the world about these L7 policies, routing, and those sorts of things, which we have to build up from, which isn't itself a bad thing. It's not bad to be layered, but I do feel like network policy is like the lowest possible abstraction you could imagine.
I'm pretty sure there was also just an element that you have to get it working quickly. Like you wanted Kubernetes to succeed quickly, and for that, like you need to have a working solution pretty quickly and then start optimizing from there. I totally understand that as well. I think that makes a lot of sense.
So I think maybe seeing some network policies visually might be a really helpful thing to do at this point. So Thomas, would you like to share the new network policy editor?
Yeah, so maybe to give a bit of context on kind of why we're doing this, I think most of you on this session probably know that Kubernetes itself does not provide a network policy implementation like you use in like a CNI, like OpenShift, SDN, Cilium, Calico, like others that implement network policy. That obviously leads to a situation where a lot of the documentation. Let's see if I can share my screen. It worked before. Not really. Something changed. Let's try again. That obviously leads to a situation where a lot of the network policy documentation is in those projects. At the same time, the network policy is fundamental, right? Like we all benefit from users running Kubernetes in a secure way. So we found it fundamental that like any information around network policy, around Kubernetes security is applicable and widely available to everybody, no matter what CNI you use. And the most part of like, for example, the Cilium network policy documentation is actually generically applicable to everything, not just the Cilium part. So we found it important to create a resource, and we've created Network Policy IO for this, where we can share all of the resources we have, like documentation, tutorials around network policy, and also this, I think, nice little policy editor, which we've put together, and it became a huge success. If you have used network policy so far, you probably have been doing so by writing YAML files. While it's definitely possible, and I've heard some people actually like to write YAML, it's probably not the most user-friendly way to get started. So we have been thinking around what could be a better way or like an easier way for newcomers to get started with network policy, and we've come up with this editor, like this network policy editor, that actually gives you a nice little tutorial on how to get started. So to explain the view here real quick, it's very basic. You have this visualization at the top, which actually describes what the policy allows. So you see in this case, it's all green. So everything is allowed. You kind of see the ingress side, you see the egress side. On the lower left, you see the YAML description. And then we have a tutorial that kind of guides you through the thinking process that you can apply to get to a good security posture. For example, I can go in and, for example, allow or enable default deny ingress. Let's enable this. You can see it now turned red, and I can, for example, now allow everything from the namespace. So I can go in and say, allow everything from within the namespace. You see it's visualized here, and you see the YAML that was generated. So this allows you to get to network policies pretty quickly without actually remembering all the specific details. The one mistake I've definitely seen the most is users confusing default deny and allow everything. The syntax is kind of similar, in particular with the old notation. That was definitely a common mistake. So with this editor, with this visualization, you can create policies, but you can also upload policies and kind of validate what you're actually doing. And pretty nice here as well, we've added this neat little feature where you can rate your policies, right? So based on how restrictive they are, you get a policy rating. So if you open up widely, you will get a much worse policy rating. So let's say if I open up, let's enable default deny egress here. So let's lock that down, and let's now outside of the cluster to any endpoint, like everything. So it's wide open. You can talk to the entire internet. That gives you a much worse rating than, let's say, we change this and do an FQDN or a DNS-based policies. Various CNIs already support this as well. So let's say to FQDN, and let's do start.networkpolicy.io on, let's say, port 443. Now this will allow all IPs for which the DNS server responds to. If you look up anything in star.networkpolicy.io, that will give you a much stronger policy rating. This is also an example that shows you the Cilium specific aspect of this. So right now we have two notions or two notations in here, like the Kubernetes, the standard Kubernetes network policy, which currently does not have any notion of FQDM policy. So if you want to use this FQDM policy feature, you would have to use, for example, Cilium network policy, and you could see how that policy actually looks like. So this is, I think, a good starting point. It explains policies quite well. It gives you kind of an easy entry into using network policy. And it also, I think, even I have been using network policy for a long while. I still use this very frequently to actually validate the policy, like what does this policy really do? It's definitely much easier than to parse YAML in my head every day. So if you want to start using this editor, it's freely available. So you can go to NetworkPolicy.io, and you will find the link to the policy editor right here. So you can just start this. This is also where you find like the tutorial and so on. But I think we'll talk a little bit more about that later on.
Wonderful. Thank you, Thomas. So one of the questions that we had come in on Slack was from Walid Shari, and he was asking about what the best ways are to test and visualize network policies. I think you kind of answered the second part with that demonstration, but actually testing network policies, does anyone have any good tools or suggestions for that?
I mean, I'm happy to jump in on that one. So I think for us, a lot of the problems or the challenges often are around scale. And so it's really important for us, because we have a very multi-tenanted environment, that, as we let our tenants create their own network policies, that we can support, a maximum number of network policies being created, a maximum number of identities being created. So what we try to do is we definitely have staging environments where we deploy Cilium in the same way that we do in production. And then we have our own tests that basically exercise network policies to that point, and that's part of our release cycle. So I think we've found that testing for all of our NFRs around Cilium has been a big part, and actually we got a lot of support from Isovalent as part of our initial launch, where we were looking into using the CRD-backed Cilium implementation, where we did run into some scaling problems, but definitely by having those tests in place in lower environments, it saved us a lot of pain.
Wonderful. Dan, you have something to add here, I think.
So just as a really basic one, kubectl describe, we occasionally extend to be able to describe network policies better than the raw YAML form does. So especially if you have a network policy and it's doing something wrong and you can't tell why, that can sometimes help you debug it. But it does need to be better. There are people in the SIG network policy working group now who are thinking about things like debugging and explaining network policies.
Great. Thomas, you also have something.
I think various CNIs, I'm not sure about OpenShift, you can correct me, Dan. I think various CNIs have some sort of audit mode as well, where you can load network policies, and instead of really dropping the packet, it will signal that, yes, this would drop the packet. So you can audit policies as well in a, for example, staging environment. I know some people even do this in prod to get to like, don't really drop it, just warn me for now so I can test my policy, because I'm not 100% sure what it's actually doing. I know of at least 2 CNIs, including Cilium, that can support this feature as well.
Yeah, I think it's a pretty popular feature of security tools in general to be able to run in some kind of audit mode, so you can see the effect before plugging it into production. All right, I think it would be wonderful to hear a little bit more about network policy in a production use case. So perhaps Liliya and Eric, I could ask you to tell us a little bit about your use of network policy at Datadog.
Sure, let me start sharing the slides. Okay, can you see the screen?
Yes.
Great. So Eric and I will be talking about network policy at Datadog and how we use them.
Yes, so network policy in our case was very much compliance driven. FedRAMP notably is something that we've been working on for the past year or so. And so definitely as part of hardening our systems in order to meet these requirements, we felt that we needed network policy. In other words, to have firewall segregation of our workloads in our Kubernetes clusters. So we actually work with a full enforcement mode. So we basically go slightly beyond the style where network policies only become enforced once a network policy is enforced on a pod, like it comes in scope of a network policy. We actually dictate that network policy, only the traffic that's explicitly allowed by network policies will be able to flow. So we do this for all the traffic within clusters, apart from the host network traffic, because the CNI that we were using, so Cilium as it happens, was growing host network policy, but it wasn't yet ready, and we didn't feel that we wanted to go that path, at least not straight away. And the other aspect that we control significantly here is the actual ingress egress from the cluster, and including the internet, because that's actually a real boon, I think, of being able to clamp down on egress traffic to the internet from a pod that might have been taken over by an attacker or something. Just not allowing that by default is great.
So adopting network policy was a process for us, and now we would talk about what we think went well in this process. So first of all, we introduced network policy very early in the cluster's life. That made it possible for their applications that need to run in this cluster to have network policy creation as part of their deployment and bootstrapping process. So that prevented from any potential traffic interruptions that might have happened if we started adopting network policy for existing and like running cluster. The next good thing is that we were very careful with choosing the policies and the selectors that we want to enable. So in many cases, it was very specific to the applications, and that allowed to defer loading of the policies only when they need it. And the last but not least is making policy creation easy for application developers by providing very comprehensive documentations. So application developers would see our recommendations for what rules to use or to avoid, what are the gotchas, and for them, writing the policy became easy just by taking the examples that we provide for them and adopting them for their services.
Yeah, so going on from there, some of the points where we thought we could improve. So writing the guidance was a big piece of work and was very useful. We needed it in order to be able to communicate with the applications, to help them learn and help them write their own network policies. This was still very much a big communication burden. We had to go and talk to the teams an awful lot. It was difficult for them initially. However, I'm really happy to say that all in all, it's very low bandwidth nowadays, the support that we do for network policy in the sort of platform teams. And for instance, from an incident perspective, it's been almost boring. It just worked well. We had, a few little problems that people needed help with over time, but it's really been adopted quite well. We still, as I mentioned, host network was a challenge for us. We haven't used the host network policies yet. There are some of our workloads that would benefit. And we definitely like to use more of the policy types that exist, that are available through Cilium, for instance.
Yeah, and just to add to Eric's point, we're also looking forward for adding any new policy types, maybe anything based on the XDS control plane that would fit nicely into their work that a lot of companies are doing. So the next thing we believe would have could be improved is adding automation for policy generation and validation. Talking to the application who wrote those network policies, it was one of the pain points for them. Just some small error in YAML file in indentation would cause policy not working and lead to additional debugging time. And also tools around linter and figuring out what network policies applications actually need to deploy would also be nice to have and would simplify lives of application developers. That's it from us. Thank you.
Actually, if I could just add one small thing, which was we would really have benefited from the network policy editor at the time. I mean, from the point of view of educating the applications and allowing them, to see what they were doing, what they needed to do, I think it would have been a great bonus.
Should I quickly say something about the host networking side of things?
Go ahead.
Definitely can.
I gotta think that you're not the first user asking this. So for those maybe not fully understanding like what that meant is like network policy currently does not apply to host networking pods. And the reason for that is, like Tim referred to this, host network or network policy has been based on IP tables, which basically means that there was a notion or an assumption that you somehow map this to IP addresses and ports and then allow for that. For host networking pods, all host networking pods on the same node, they obviously share the same IP. So you cannot just allow an IP. You would allow all host networking pods on that particular node. So what is exciting is that with the growing adoption of cgroups v2, it's becoming possible with eBPF to derive the context of a host networking pod and actually understand the pod itself, even if it is using the networking namespace of the host, which means we will be able to address or make standard network policies be applicable to host networking pods as well, which I think will be exciting. It's probably what most users expect right now, but probably are surprised that this is just a loophole. Like I think unknown to most, and it's kind of just out there, kind of unexpected and kind of a security hole unknown by most. So with cgroups v2, it will become possible to provide a good solution here.
Can you clarify will become possible, or are we still waiting for more stuff in the kernel, or is it just that we need to start making use of what's already there?
It's basically just like further use of cgroups v2. It is growing, but that's like, I would say right now it's still 95% is still cgroup v1. Like if Kubernetes had to change, so cgroups v1 does not making it is almost impossible to derive this properly. Like in cgroups v2 has the hierarchical model, which makes this possible.
So we got a couple of questions come in specifically about Datadog. One is really about how you onboard a new app or a new project, and does your network policy already allow for shared services like monitoring, logging, secrets management, or how do you help those application teams manage the network policy for those kind of shared services? Liliya, do you want to take that?
Yeah, I can take that. So we definitely trying to put the services that are used by many different applications as part of cluster-wide network policies. So that make it easy for services to need only dependencies specific for their application to the network policy, while we are taking care of setting up network policy for any commonly used databases, anything like that.
Great. And actually, we didn't really mention this already. Would anyone like to speak a little bit to the idea of cluster-wide policies and namespace policies and the interactions between them? Tim, maybe you can speak a little bit to why those came about in the first place. Yeah.
So the goal with network policy and a lot of Kubernetes was to really put a lot of the self-service power into end users' hands. So if you own the namespace, you can define how your application works, and it's like a little mini virtual space for you yourself. what we've come to realize since then is that gives a lot of power for network policy for app owners to define what they want for policy. So I think one of the things that is missing from the open source definition, and that a lot of the vendors have chosen to augment in their implementations, is a cluster scoped policy that is guardrails for what users can do within their namespaces. And so there's an open discussion going on now with SIG Network about adding a cluster network policy API that provides some bounds and norms for cluster administrators to dictate for their users.
Great. And we also had a question in Slack from one Tim Hockin for Datadog folks. Do you expect end users, i.e. namespace users, to write their own policies RBAC for managing network policy, or do you centrally manage them for them? I guess this is, how does your RBAC, how do you set up your RBAC in terms of how it controls access to those network policies? Eric, would you like to answer that one?
Yeah, so so the cluster-wide policies indeed are managed by the admins, so the platform team. The application-specific network policies are up to the applications to write. So they do write they have the RBAC that allows them to write network policies for the namespaces they own. However, so that with respect to the concerns about over-opening policies, so that definitely exists as a concern. However, they are limited to creating network policies that scope to their own namespace. So the damage is somewhat limited, and then it's down to auditing and things like that.
Wonderful. So I think before we get into discussing some of the things that we can learn from, some of the traps that you might fall into, I think it would be great to hear about the Sky use case as well. So Joe and Peter, if you'd like to take over, that would be wonderful.
Sure. It's actually good timing because we're talking about cluster-wide network policies. So just some context. So again, let me just make sure that's working. Let me know if you can see that.
Yes.
Okay, so just some context for the talk. We manage a platform called the Core Platform. It's a platform as a service that's built on top of Kubernetes. And a lot of our challenges come from the level of multi-tenancy that we have in our environments, and the goal to give as much autonomy to our tenants as possible. So we're going to look at two use cases, one that we briefly touched on, Tim briefly touched on, and a slight variation. So the Core Platform itself hosts services from multiple different departments, and these are really large autonomous departments, almost like their own organizations, hundreds of engineers inside it, and well over 1,000 engineers using the same clusters. They have a lot of autonomy in deciding the tech stacks that they use, and their software delivery lifecycle is really independent as well often. And so what we do as a central core engineering team is we provided a common abstraction layer to really deliver on the hybrid cloud strategy that they have at Sky and NBCU. And that allows us to concentrate the effort on a small set of infrastructure teams to do all the cloud provider integration. And the combination of these abstractions that we've built, which are mainly controllers and operators, and the underlying infrastructure is what we call the Core Platform. And so really our mission is to give these independent teams that have their own services full service ownership all the way to production. And so we're going to look at how network policies play in that. So the first thing is we needed to implement a central overriding deny list. And so if we just start off with our clusters and the tenants, we know that network policies can allow us to create a perimeter around the namespace. And like we were just saying, we want the tenants to really be the only ones managing that network policy if possible. What we do as a platforming team is we either use a gatekeeper or custom admission controllers. We'll try to ensure the right level of governance is in place as part of them doing their day-to-day changes to that network policy. So after that, a requirement came in from a central security function, and it's slightly different for the Sky case and the NBCU case, but ultimately they had a default deny list that they wanted implemented at the perimeter, and that needed to be as soon as possible from the change. And this is really to prevent egressing out from our clusters to known malicious endpoints that they've identified through through that threat intelligence that they run. And that's really where cluster-wide network policies made a massive difference to us and simplified the scope of that work, because it can create easily a perimeter boundary for us. And really what's left for us to do as a platforming team is just build a service that integrates, their deny, that syncs up their deny list, with that network policy. And I think it looks pretty simple, but it actually, from a delivery perspective, made a massive difference, because we're not really dealing with a greenfield environment. We've been using Kubernetes for about 4.5 years now. And so a lot of these environments originally were very permissive. And so as part of, expansion, there's been a desire to move to a default deny strategy for all of our networks, including within the cluster. And so the difficulty really there from a pragmatic perspective is, how do you take 90 teams that are managing 300 applications and that have been in permissive environments, for the last 7 years, and do a big bang perimeter, default deny, which was, the original suggestion. And so really by being able to do the controls at that namespace level, it allows you to roll out more aggressively a move towards a default deny by targeting, your most important components, most important teams, and you're not waiting for the whole cluster to catch up before you can implement a default deny strategy. So there's two real things that we were trying to achieve here. One, really a default deny through the namespace network policies, which we do by following governance and chasing up on teams, but then also giving our security team the confidence that they can deny any egress out of the cluster centrally. So that's one use case. Pete's going to walk through the second use case that we have, which is a slight variation on this. But again, it's really a focus on how do we enable the service owner, which in Pete's case is going to be about a database team. How do we give them all the access that they need to administer access control to their resources? So Pete, over to you.
Cool. Cheers, Joe. So if we start with a similar diagram, so we still have the same state of the cluster, where the Kubernetes cluster, the namespace within that cluster, should be owned, maintained, and managed by the tenant. So not by the team that's maintaining or hosting the Kubernetes cluster. We want that control to live with users of the platform, to give them direct access to the underlying Kubernetes resources, rather than having any sort of interfaces that would abstract them from that layer. And as Joe said, we would still be including that admission controller to do sort of standard sanity checks and sort of governance. But from then onwards, we would want the access to be as vanilla as possible. So the second use case is around securing access to external resources. So as Joe talked about, a really good example for us, and this has come up already in production, and we're following this exact model in production, is we need to allow only a subset of namespaces to be able to access a database that lives outside of the Kubernetes cluster. So the core platform that Joe was describing primarily hosts stateless apps. All of the persistence will live somewhere else, owned by a separate team, still living on a private network. So in this example, we've got a Class A range that hosts our Kubernetes cluster, and then a Class B range, or a different CIDR range, which is where the database lives. So effectively, the requirement comes in from the DBA to say, we only want to allow 1 or 2 namespaces or teams access to our database, because it's a very secure database. And in a standard sort of firewall model, we would probably have firewalls in between the 2 services, and it would be very easy to restrict that. But with our model, because it's multi-tenanted and we don't have dedicated hosts, and we wanted to try and keep it as homogeneous as possible, the actual source IP addresses, when the applications try to contact the databases, will come from a very large range, and it will not be application or Kubernetes aware. So this is where cluster-wide network policies came in for us. So what we have done is we've effectively applied a global cluster-wide network policy that restricts access to that 172 address range in this example, and it effectively moves that perimeter that Joe was talking about for the egress access over to the actual database from within that cluster. So obviously outside of the cluster, it's completely separate, but from within that cluster, the access is restricted to needing to abide by that cluster-wide network policy. And we've also used new features within that cluster-wide network policy around tagging. And this effectively allows us to state that only given namespaces that fit certain tags are actually able to egress and talk to that database, which effectively allows us to still grant application teams access to their namespaces, but also allows those DBAs to be able to create these network policies. And the last little section, I think, if you go next again, Joe. So this is where the actual creation of the resources come in. So it's kind of V1 of this design is we have a core team repo, which is where all of the resources live, which is where this cluster-wide network policy would reside. The database team would then request to own that range and create the cluster-wide network policy and only allow access via a certain subset of teams. That would then be put in to the cluster via a PR process currently, and that would then be applied. The next kind of iteration for this for us, because we effectively want to move ownership of resources, and in this case, it would be that cluster-wide network policy to the owner, which in this case would be the DBA team. So we're currently looking into ways in which we could actually allow teams to have some sort of CRD that they create that they would then own a given CIDR range. And then based on that, we would be able to create various gatekeeper constraints or potentially some cluster-wide policies that would then allow them to actually create cluster-wide network policies and allow teams that they would have awareness for access to their database layer. But that's more sort of V2. But that's kind of the design at the moment. I don't know, Joe, whether you wanted to add anything extra to that.
No, I think that's right. I would say that we definitely would never really want to leave it in this state, because our priority is always to minimize the interactions any of our tenants, including the DBAs, have with us as a platforming team to do their job on a daily basis. So very much the goal is to replace this PR mechanism with, like Pete said, a CRD mechanism that would allow the DBAs to control access to their secured resource from our cluster once we've given them ownership over a CEDR range, which would be a far less frequent event. Yeah. So I think that's it for us. Let me stop sharing.
Thank you very much. One question that came in over Slack from Saurabh Sarika for Joe. Did you start off with a perimeter firewall, and are you migrating completely away from that to network policy solution?
So we have multiple layers of firewalling. So in the AWS context, we do network ACL security groups, and that's really what we do for the host level. But the identity capabilities of Cilium is so powerful that the vast majority of the network policy, the network segregation that we want to achieve is within the cluster. And so we try to treat all the host level resources as very generic and not team specific or department specific. So I'd say we have multiple layers of firewalling, but the majority of the segregation happens inside the Kubernetes cluster. But I don't know if Pete, if you wanna add to that.
I think the only other thing that I want to add to that is I think historically firewalls have been quite difficult to scale, and we've definitely had these issues in the past at Sky. And as Joe was talking about, a requirement came in to add an egress firewall, so you could have put some sort of firewall on the NAT gateway. But for us, we felt that it's very difficult to scale that NAT gateway to support that sort of level of firewalling. So when we looked at it and we looked at the current state of the cluster, we effectively had a distributed firewall in the state of Cilium effectively, and we wanted to try and move the firewalling and the actual offload the compute that firewalling actually takes to the cluster, which allows it to organically scale with the cluster. And as the cluster grows with the applications, we're actually effectively scaling that distributed firewall, which is really important for us, as well as all of the additional functionality we get where you have a Kubernetes aware firewall, which was a number one goal for us when we were building this.
Kind of related, or at least if we think about egress, there's a question came in from Ben Grissinger talking about solutions for managing ingress and egress rules, perhaps an integration with service mesh. What are the best solutions for managing ingress and egress? Who would like to take that? Thomas, you look like you.
Yeah, I think it's actually probably like a very complex topic overall. So yes, I think service mesh integration and overall, we have very much focused on like what's happening inside of the cluster. We briefly touched on like stuff egressing the cluster, and for example, how you could represent that. There was a chat in the Cilium Slack around like external VM or external workload support. But probably I think the complexity today is actually less in the traffic that's inside of the cluster, but like how do you control what's going in and out? And how do you expand the concept of identity, which is very simple in the cluster? How do you expand that beyond the cluster? How do you understand the identity of the true clients, like the actual end user or user who is making requests into the cluster? And how do you find and manage identities of external things, legacy things that might not be Kubernetes aware? To some extent, like DNS is a quite practical like patch that just allows you to fix it, but it's not obviously not like a true notion of identity. So I think we actually want to get to something stronger. So for example, understanding TLS natively and understanding like the identity that TLS provides, but also understanding identity better of, for example, cloud provider resources. Let's say a Google Cloud resource like a Google Cloud instance or an EC2 instance. These things have identities as well, and whatever is enforcing policy inside of the Kubernetes cluster can understand these things and actually enforce it as well. And I think in that context, there is a lot of overlap with what Service Mesh attempts to achieve as well. It's also about understanding identity as much as possible and building the security model on top of that. I know this was kind of high level, but I think that's kind of how I see it. This means that typically, I think right now you are in the best possible position if you combine like a service mesh with something, for example, like Cilium that has this understanding of identity as well and can still give you like FQDN, DNS policies, and so on. I think in general, like the service mesh portion of this and something like Cilium is shooting into exactly the same direction and working off the same user feedback.
I'd be curious if any of our end user guests are using or considering service mesh, and how, if so, that might interact with your network policy. I see some shaking of heads, so I guess that's going to be a no. Anyone else want to add anything while we're talking about how network policy and service mesh interact? Okay, I think kind of related. There's a question from Ricardo Katz. Assuming that we're just talking about Kubernetes network policy rather than any of the extensions from Cilium or Calico or any of the other network plugins, any additional CRDs, what would you want to see evolve in network policy? And I suppose one answer to that is the things that currently exist in the individual networking solutions. Eric, you have a...
Well, I can try and take a bash, but the problem is we actually chose to use Cilium network policies explicitly because I think this takes us back a little bit, so I'm not entirely sure, but I seem to remember that at the time, some of the features that we wanted weren't in raw network policies or Kube network policies. And so we actually decided to use Cilium CRDs for that reason, thinking that simply we would be able to translate them later on if we did want to, through some automation, but we would be able to translate the YAML or the CRD from Cilium network policy to network policy. That's how we worked it.
Dan.
Yeah, so you said this is Ricardo Katz who had asked this question, I think, and he's one of the people who's been heavily involved with the network policy working group. And one of the things that they're working on is cluster-wide or cluster scope network policy with administrator overrides, which sounds like is a lot of what both of your solutions were needing that the base Kubernetes network policy didn't provide. So hopefully we're not too far away from base Kubernetes having that functionality, or I guess
fantastic,
all network plugins having that functionality.
Ricardo actually linked to the a discussion on GitHub about those cluster scope network policies in the Cilium Slack. So if you're watching, you'll find that link there. Eric.
Yeah, I think possibly cloud provider integrations might be one as well. Things that work with, I don't know, AWS security groups, GCP firewalling, the similar kind of thing. Those kinds of things might also be helpful. I don't know. It's all related. I think it all boils down to service discovery of some kind, in that you want to be able to have network policies that apply to whatever traffic you have and make it reasonably fine-grained.
One of the things that, sorry, one of the things that I think is interesting about that idea is the idea of defense in depth, right? Belts and suspenders. And so I would love to see more integrations that push deeper into the infrastructure that's provided, move stuff off the hosts, or on host and off host. We get away with a lot of stuff in Kubernetes because we run on every host, and so they're all participating in the sort of Kubernetes mesh. It gets a little more complicated when you start programming cloud APIs and you expect the same sort of sub 1 second response times that we typically see when you're running inside of a cluster. So I think that's an area for interesting exploration.
Now, one area we haven't talked about yet, and I think could be really interesting, is things that can go wrong, traps that you can fall into. What are mistakes that people may make, perhaps you've made yourselves, when first implementing network policy? I think Eric beforehand. Oh, Joe, you've got your hand up.
I'll do a quick one. And I think for us, like when we first started using Cilium for network policy implementation, it was just important for us to understand how identities work and the number of identities that get created based on our different configuration. And it was, again, just about performance testing for us. So I think that was a learning curve. But again, like we're really confident with it now, and everything did end up working with the right configuration and so on. So, but definitely, I would say if you're at larger scales, it's worth trying it out somewhere before you go into prod at scale. Yeah.
Thomas.
So I think the most fundamental issue I've seen is, I think the assumption is the Kubernetes will automatically, Kubernetes created by Google, it's going to be secured by default, right? That was the expectation. And I think in a lot of ways, it's not a completely wrong assumption. Kubernetes has a lot of concepts which make it very, very easy to get to like zero trust and least privilege and so on. But yeah, if you're not creating any network policies, everything is allowed. And I think wide range of users still don't fully understand this. So that's, I think, where it actually starts. Like even just understanding you're starting out with like an entire flat layer 3 network. Everything is allowed to talk to everything, which is great from a connectivity angle, but it's the worst possible scenario for anything, for any type of lateral movement protection. So that's, I think, step one. And then there's pitfalls, I think, in how you use YAMLs, which is kind of why we created the editor. Those are the two major problems we have seen our users fall into.
Liliya.
Yeah, so I think for us, the most important piece was creating a good documentation and communicating to application teams how to write policies and educate them and help them initially to get used to writing the policies. So we really removed this bottleneck of platform team being responsible for writing every application's network policies, and we could delegate this process to applications.
Great. I think one other trap that we kind of have to mention, because you can't have a discussion about things going wrong in networking without mentioning DNS. But I think it's a reasonably easy thing to do to sort of prevent DNS traffic and then wonder why nothing can find any other services. And I think we actually have that in the network policy editor. It will highlight if you aren't enabling DNS.
Yeah, there's this big fat warning. If you're not enabling DNS, there's this warning because like everybody falls into this trap. Like most policy examples you see, here is how to allow pod to pod. But then I think the notion of that you also need DNS and ideally you also need ICMP. That's kind of hidden, right? It's not in the mental model if you're talking service to service that, hey, there is things like DNS and ICMP and other control protocols. Yes, definitely another, I mean, it's always DNS anyway, but like even for network policy, it's definitely quite frequent as well.
Eric, did you want to add something there? You're muted.
To the DNS part, I think we actually took the path of making that a cluster-wide policy. I think cluster-wide policies, one thing I will say about those is do be careful and very selective about which ones you do, because once you've made a cluster-wide policy, it does tie the platform's team's hands to some extent. So they're going to have to maintain that, and evolution is going to be complicated. And I think the other thing is, if we mention DNS, we have to mention YAML, right? And YAML indent and things like that. I think it's actually already been mentioned, but it's one of those. We actually got away fairly well with that, because once we had the documentation out there, people were doing a lot of actually copy-pasting YAML, and that helped an awful lot get the indents right, I think. I fought an awful lot getting the indents right in the documentation, though.
In historical context, right, Dan, I don't know if you were participating at this point, but right before network policy was going to go GA, we found some gotchas that we had not handled properly, and we made some last second changes to the API and then went into GA with those. And I think those are the things that people tend to trip over the most. It's the places where the YAML, like the existence of a dash or not dash, changes the meaning. It's valid in both ways, but it completely changes the meaning of the YAML. And so like in hindsight, that was kind of a mistake, to rush it, and B, to make it so easy to get wrong. So, you know, Kubernetes has this this guarantee that we can version the APIs and provide round trip compatibility. So one day we will open a V2 discussion on network policy, and one of the criteria for a V2 will be less easy to get wrong.
In fact, I'm seeing in the Slack channel, Ricardo posting a link to a document about V2, network policy V2 guiding principles. So it sounds like that conversation is imminently arriving. Okay, we're just getting towards the end of the hour. It would be great, Thomas, if we could just quickly talk a little bit about the purpose of the networkpolicy.io site, and more importantly, how people can contribute to what we're doing there.
Absolutely. So as I mentioned earlier, the purpose of NetworkPolicy.io is to create a community-wide resource and not hide all of the network policy, all of the generic documentation that we have in the Cilium docs, and kind of bury them in the Cilium docs, and only Cilium users benefiting. So we created NetworkPolicy.io, and we are inviting everybody to participate. So it is completely open. So we have like the website itself, and then we have a GitHub organization, Network Policy, with multiple repositories. The source of the website will become available here. We started putting the policy examples that we have in here, for example. So let's look at the default, deny, and so on. So all of the Cilium policy documentation examples we started to move here, because I think no matter whether you're using OpenShift SDN or whether you're using Cilium, like this still applies. So it does make sense for us to have this like community-wide documentation. There is also a tutorial that we have on here. Like part 1 is already available. If anybody wants to provide additional tutorials, or if you have something in your own repo or something, or somewhere hidden, and you want to make that widely available, feel free to contribute. We are taking all contributions, as long as it is open source, as long as it is about Kubernetes network policy. We will also have, I think, the video up here. So where's the website? So the video of today's recording will be here in the resources. We're starting to have like a blog section. So if you have network policy related blog posts, we can link them here. This should become the community-wide starting point for people starting out with network policy. It should be in an unbiased way of talking about Kubernetes network policy itself, and the purpose is to help everybody get to a better security posture, no matter what CNI plugin you're actually using, because like 90% of what matters when you get started actually applies to all the different CNI plugins. So again, if you're interested to collaborate, if you have resources to share, we would love to have them. If you want to be a co-maintainer of the site, like feel free to ping us. We are happy to share. this resource and make it and kind of allowing everybody to contribute. If you're new to network policy, or if you're looking for these resources, feel free to dig around, browse around. There will be more and more resources coming here as we extract the pieces of information from our Cilium specific documentation.
Wonderful. So we're getting to the end of our allotted hour, and I want to respect the time of all our panelists who've been so generous in sharing their stories with us. Everybody's in the privacy of their own homes. It's giving you all a giant round of applause, honestly. Thank you very much for your time and for your stories. The Slack channel will be there, indefinitely. So I know there are questions we didn't have time to cover. So we'll try and get to those in the Slack discussion. We welcome more questions. And if there are things that you would like to see us doing related to network policy, hit us up and do ask. So with that, giant round of applause to all our panelists. We should have canned some cheering to make it feel like a proper audience. But thank you very much.
Thank you. Thanks, Les, for hosting us.
Thanks for having us.
Yeah, thank you.
Wonderful. I see some applause emojis appearing in the Slack channel, so that's good.